Okay. So I wanted to go ahead and redo, right, the first part of chapter 10, right? So chapter 10, right? It's around RSTP, right, and Etherchannel, right? Etherchannel, right? And this whole chapter is understanding those concepts, but through configuration. Okay, right? And so the exam topics, right, that is going to be covered in this chapter, right, ultimately is going to cover network access, right, 2.0, right? Under that, right, 2.4, configure and verify layer 2 and layer 3, right? Etherchannel LACP, right? So we're going to go ahead and do labs, right? Lessons around labs to cover that, right? Um, 2.5, interpret basic operations of rapid PVST, right? Rapid PVST plus, right? So rapid per VLAN spanning tree plus, right? You guys are going to see that. You guys are going to relearn, and you guys already learned about it in regards to theory about the root port, root bridge, I mean secondary. You guys are going to learn about port names. You guys are going to learn about port states and port roles again. You guys are going to see in action how port fast works. And you guys are also going to see root guard, loop guard, BPDU filter, BPDU guard. Guys, all of this is going to be straight up. We're labbing this together and trying to learn through configuration, right? So even if I mess up, we're just going to mess up in the lab, right? This is how we're going to learn. So we've talked about previously spanning tree and the graduation, right? The graduation of the protocol to rapid spanning tree, right? But what's the common thing that we see here, right? Whenever we go ahead and we go from spanning tree to rapid spanning tree, right? Is it's still circled around creating one common spanning tree, meaning we can have 40 VLANs. We can literally have 40 VLANs, and it is still going to go ahead and use the same spanning tree, right? It's ineffective. It's ineffective, and we prove that, right? And again, this protocol spanning tree was created back in 1990. I wasn't even thought about. I mean, my parents met, but I wasn't even thought about, right? So now we get to 2001, right? We get to 2001, per VLAN spanning tree was created. And then, right, we talk about, right, per VLAN spanning tree in the previous chapter, and we've learned, excellent, we can have a spanning tree instance, right? A spanning tree for each VLAN, and we can manipulate it on how we can manipulate it for each VLAN, right? No matter how we want to do, of course, we'll influence that via configuration, right? So there's no common spanning tree on VLANs. How can we make this better, right? So again, going to 2002, we now have rapid PVLAN per VLAN spanning tree. Okay, right? So we have that set. So now that we got that squared away and we realize the difference between regular spanning tree or rapid spanning tree that's only centered around a common spanning tree, and we have now PVST and rapid PVST plus that is around one instance per VLAN, right? Now we have to learn how this works. Okay, so let's go ahead, do some checks in the lab and try to understand how all this works. So first, let's see what mode, right, our switches, right? And I'm on switch one, what mode our switches are operating in. Okay, so let's go ahead and do show spanning tree. Okay, all right, so it's operating in rapid spanning tree mode, right? Okay, right? So we confirm that, right? Let's go ahead and confirm that the mode that we can change it to or that it's already on is rapid per VLAN spanning tree, right? Let's do mode, right? So we're going to go ahead and go. And sorry, I'm typing a little bit fast. Let me go ahead and slow down. I want to make changes on the switch, as you guys learned before. We need to go ahead and go to global configuration mode. To get there, right? We need to go ahead from privilege exec mode. We need to go ahead and type configuration terminal or configuration terminal, right? I shortened it and typed in configure T. That brought me to global configuration mode, right? Once I got there, I know, of course, to go ahead and change the spanning tree mode, I need to type spanning tree and, of course, mode, right? And I'm going to do a question mark because I want to go ahead and see how that works, right? So we have multiple spanning tree, right? And of course, you guys don't need to know this for your exam, but multiple spanning tree, right? What does that allow? That allows for many spanning tree instances or MSTIs, right? For multiple VLANs, right? Per instance. What does that mean? So we can have the same spanning tree, right? Same tree, right? For multiple VLANs. So VLANs 1 through 50 can have the same tree. But VLANs 51 through 100 can have a different tree using multiple spanning tree. Okay? Makes sense? It's basically what we can do in rapid PVST. That is, MST is basically the industrial version of that. Okay? All right. So we also, let's look at the different modes, right? We talked about MST. We have per VLAN spanning tree, but we also have rapid PVST, and that's what we're focused on. So let's go ahead and configure that, right? And it's probably already configured, right? But we're just going to go ahead and make sure, right? Because we always want to trust but verify. We're going to make that configuration. I have a bad habit of saving my configuration when I make a change. Actually need to stop doing that in my lab, okay? And now that we made that change, let's go ahead and do show spanning tree to see what are we running, right? Excellent, right? So the first thing I'm going to look at, right, is of course I'm going to see the VLAN, but I also want to see what protocol is running. So it's RSTP. So that means, right, we can interpret on the switch that this means rapid PVST is running. Okay, we can go ahead and confirm that. All right. So now that we understand that, let's go ahead and check our other switches and just make sure those are running the same exact configuration. Okay. So let's do show spanning tree again. Okay. All right. So this is where we do need to go ahead and actually add the configuration. What this means is this is running old school STP, right? So the timer's a little bit whacked out. We got an extra 30 seconds in regards to convergence, right? Listening and learning within the process whenever topology change happens, right? So we need to go ahead and make sure we change this so that the entire topology is running on the same timers, right? And it's not slowed down, right? You guys are probably thinking, okay, how does rapid spanning tree work, right? With, right, spanning tree, right? Old spanning tree, okay? Is it backwards compatible? Does the timers, go back to the spanning tree timers, right? Are the are the modes, right? Listening and learning that was removed going from a spanning tree to rapid spanning tree, is that added back? Yes, yes, and yes. Right. So 15 seconds is a lot of time, right? That's 15,000 milliseconds. Let's go ahead and make sure we change that and make sure our entire topology is running the same version of spanning tree. So how do we do that? We are currently in privileged exec mode. Let's go ahead and go to global configuration mode by typing in configure terminal, so that we can go ahead and make this change. So let's go ahead and do that. All right, configure terminal, excellent, right? So now we're gonna go ahead, we're gonna do spanning tree, we're gonna do mode, excellent. And we're going to change it to rapid PVSC, right? I'm not going to save my configuration. I am first going to check if that change was applied. Excellent. That change was applied. We actually see that. We're going to save this. And now we got to apply this to switch 3 because we already went ahead and confirmed this on switch 1. Okay. So let's go ahead and go to switch 3. All right. All right, we're in privileged exec mode. We're going to go ahead and go to global configuration mode. Excellent. All right. And before we do all that, right, skip the step. Sorry, guys. Let's confirm that we're running. Awesome. So we're running regular spanning tree, right? So STP, let's go ahead and make sure we change that so we're running rapid PBST. Okay. Let's do spanning tree mode. Then we're going to do rapid. Excellent. Right? We trust but verify. Let's go ahead and check our work. Awesome. Right? So we have all that. Let's save that. Excellent. Okay. Awesome. Right? So we got our stuff done. We knocked it out. Right? go ahead and minimize that. Excellent. So convergence is still going to happen when it happens. So what are the things? Oh, it looks like it signed me out of. Looks like it signed me out of even G. Let's go ahead and fix that. Boom. There we go. Try that again. There we go. Awesome. All right. So pull this back up. So, right, let's talk about, right, and again, we're learning through configuration. That is the goal of this chapter, right? The bridge ID and the system ID extension, right? So let me go ahead and share my other screen, right? And this is coming from, this is all credit to the text, right, from the book, right, that you guys saw. So here's what represents the system ID extension, right? And we're going to see this in the whenever we do the show spanning tree, right? But let's make a little bit of sense of it, right? Within, right, within that BPDU, we have committed 8 bytes, right? 8 bytes that's directly committed to your bridge ID, right? You have 2 bytes for the priority. You have 6 bytes for the system ID or the MAC address, right? And again, those 2 bytes, what do we have within it? We have, right, the priority that is in multiples of 4096. Okay. And then we have the system ID extension. What does that mean? That typically holds the VLAN ID. Okay. And we're going to see this in the CLI in a second. Then we have, right, the rest of the 6 bytes, we have the system ID, aka the MAC address, right? And again, when you guys were learning in the last chapter about, right, whenever we're making decision about port roles and port states and the type of switch, the root switch, the designated switch, the non-designated switch, the bridge ID matters in all of those decisions and those tiebreakers. Okay, let's go back to the lab. Okay, so we go to take an exam, right? Or you guys are in your lab. How can I go ahead and confirm these things, right, from the switch? If I'm at the exam site and all I have is a marker, my license, a piece of gum, and earbuds that go in my ear so I don't hear people like farting and doing whatever they do, right? I can go ahead and confirm, right, the 8 bytes by looking within the show command, right? And with this, within the show command, I can see a few things, right? I can confirm, as we went over before, what spanning tree mode is running. Okay. I can confirm, okay, the bridge ID of the root. I can go ahead and confirm the information about me as a switch, my own bridge ID. Okay. So let's take a look at this stuff, right? So the root bridges ID, right? So we got the priority, right? So first 2 bytes, right? Four bits of the 2 bytes, right? I see the first 2 bits. That's the priority. 32,769. Okay, right? And this is the priority. Also, the system ID extension, right? From the root bridge. This is what I have. Okay. All right. So by default, right? If you don't make any changes to configuration, your switch, every switch, right, it's going to start off with a priority of 32,768. Okay. With that, any number additional to that is going to be your VLAN ID, right? Or that system ID extension, right? So it's that priority number plus whatever the VLAN number is. So if I have 32,768 plus VLAN 1, I'm going to go ahead and get 32,769. Okay? All right. Excellent. So that makes up for the 2 bytes, right? So we got 4 bits, right? We got the first 4 bits, and we also have the system ID extension. We made it. We went ahead and allocated for that. What about the rest of the 6 bytes out of the 8 byte field, right? That says we have a bridge ID. It's our address. Okay, so we can identify that. That is that is our format for that bridge ID. We have our 6 bytes that contain our MAC address, right? We're told this bridge is the root. So this switch that we're on is the root. Okay. You guys also have the timers, right? These timers need to match, non-negotiable, right? If not, your network is going to fall apart if these aren't the same, right? So same thing, right? Our bridge ID. This is talking about us as a switch. Same thing, right? 2 bytes, right? We have that right here. 6 bytes, that address. Okay, right? And that's burned in. So we have that squared away, and we understand how that works, right? How are we going to go ahead and identify the root switch, right? Utilizing this bridge ID, right? It's an election process, right? The election process, first we're going to go ahead and look at that priority. If the priority is the same for each switch, if this has 32, 768 plus 1, right? If this has 32, 768 plus 1, if this has 32, 68 plus 1, right? We need a tiebreaker. That tiebreaker is the rest of that 6 bytes of the 8-byte field for your bridge ID, and that's your MAC address. You go to that MAC address, you see what's different. Whoever has the best one, right? And we're talking about layer 2, and I want you guys to remember that. Okay? Let me go ahead and clear this up. Layer 2, it's always lower is better. Okay? Let me go ahead and close that. There we go. Lower is always better, right? So the best value is the lowest, right? So whoever has the lowest, in this case for the election process, whoever has the lowest priority wins. If they're all the same, whoever has the lowest bridge ID, I'm sorry, whoever has the lowest system ID, which is that MAC address, okay? That is who's going to win the election of that root switch, right? And that's the first part of the convergence. We first need to identify who's going to be the root switch. Once we configure that, right? And you guys should be able to, at the end of this conversation, and if you guys are continuing to lab and look at your notes, you guys should be able to perform convergence, right? By writing on a piece of paper without any type of switch in front of you. Okay? Right? So understand, electing a root switch. We're looking at the bridge ID. Who has the lowest bridge ID? Right? Looking at the priority. Then we're looking at the system ID, which is that MAC address, right? Whoever's lowest, we go ahead and elect our root switch, right? You guys learned about what happened when we go ahead and choose our root switch. Once that happens, right, and that comparison and convergence happens, what do we need to go ahead and do? Now we need to go ahead and choose, right, our ports and our roles for that root switch. Then we're going to start the election. We're going to start the election of port roles on the non-root switches, okay? Because we're going to go ahead and elect on switch 2 on switch 3. Where's my root port? Okay? So now that we go ahead and do that, convergence is going to happen, and then the same things are going to happen. But one thing we didn't talk about in this last chapter is choosing, right, and configuring, because we're learning through configuration, choosing your primary root switch and your secondary root switch. Yes, you can actually do that. Let's take a look at how to do that. Okay? So let's go ahead, and we need to go to global configuration mode to go ahead and knock this out, right? Let's go ahead and reset the terminal, right? So let's do entry, right? And we're going to do VLAN. Let's do VLAN 1, right? And we're going to do, if I'm not mistaken, root. Now we have the option to set it to primary or secondary, right? Primary configures this switch, has primary root for this spanning tree, for this VLAN. We can do it for multiple VLANs, right? But with rapid PBST enabled, right? We can do it per VLAN on a per VLAN base, right? So we go ahead and set this as the primary, right? I think we're on switch 1. What does that do? Let's go ahead and take a look at that. Something changed, right? And we see right, that priority field changed. Whenever you use the configuration, right, of you go to global configuration mode and you change, and you actually set the switch has the primary, right, root switch per VLAN, it's going to go ahead and set the priority to 24,576. Again, we're still staying within the multiples of 4096, but what Cisco did is whenever they went ahead and created this feature, they wanted to make it to where this number was nowhere near 32,768. Okay, so it's going to bring it all the way down, right? So if we know this is what happens whenever we go ahead and configure, right? A switch has the root for a VLAN, has the primary. What is going to happen on the secondary? Let's test this out. Let's pull up switch 2, okay? And let's do the same thing, but we're going to go ahead and configure switch 2 has the secondary for VLAN 1, okay? Excellent, right? So same thing, right? Standing tree. Man, I'm getting old. All right, VLAN 1. Calvin, you should have created a script for me already, man. Jesus. Um, root, and then we're going to go ahead and set this to secondary, right? So we configure this, right? What this command did, it configured this switch has the secondary root, just in case we have a failure on switch 1, right? Um, is the secondary root in case of failure, right? So let's go ahead and confirm our work, right? Because we trust but verify. Let's do show spanning tree. Okay, so what do we see here, right? We see the root bridge ID and we also see our bridge ID, but what are the differences, right? We see what happens when we go ahead and set, right, the primary command. We have 24,576 plus 1, right? Because we're talking about VLAN 1. That's the system ID, right? So we still see switch 1 has the main root, right? Secondary, it's going to set it has 2867 too. If you do the math, that's only 4096 more than 24,576. Okay. So all that did was just make this a higher value closer to what we set for the primary, right? Using that command, right? It's real simple, real easy. You can actually set your own values, your own priority, right? To do this yourself, right? So you can set, maybe switch 1 has a priority of 0, switch 2 has a priority of 4096. You can absolutely do that yourself. This is a command, a macro that does it a little bit quicker, right? Okay. So we know how that's done, but let's see it in action, right? So for right now, right, we see switch 1 has the root, right? We know this is switch 1 because of the MAC address. Let's confirm with switch 3 the MAC address as well, right? I mean the priority, the root switch. Let's go ahead and confirm that. Let's do show spanning tree. Okay, so excellent. That MAC address belongs to switch 1, right? What happens in the case of a failure? Let's go ahead and save our configuration. Switch 1. All right. And let's go ahead and shut that down. Okay. So we went ahead and shut down switch 1, right? So let's do a show spanning tree. In seconds, right? In milliseconds, we see a change, right? We have the MAC address for this switch, right? Right. And we can tell it's this switch because, of course, in the bridge ID section, right? And it's also telling us this bridge is the root, right? Let's go ahead and go from switch 3's perspective and see how the topology changed. Excellent, right? So this is working as expected. This is working as the secondary root for the topology. Okay, came back up, right? This is the root, and switch 3 is, of course, the designated switch or the non-root switch for that segment for this tree. Okay, so again, what you guys learned the difference between primary, secondary. You guys learned the difference between rapid spanning tree, right? That only covers a common spanning tree or one tree. And you guys also learned about rapid per VLAN spanning tree, right? Next section, we're going to go ahead and whenever we meet back up on Sunday, we're going to go ahead and test, right? Configuring different instances for different different trees for different VLANs, right? We're going to go ahead and do that. And we're also going to go ahead and map out, right, the port cost, role, and the state, and how you can influence it or change it, right, to influence your spanning tree. Okay. Now we're also going to talk about the other optional spanning tree features like port fast, BPDU guard, BPDU filter, and loop guard. Okay. All right, guys. You guys have a great night.
Thanks, David. Bye, guys.
David.